All right, welcome to topic number 18, polynomial functions. So we're going to spend quite a bit of time talking about polynomial functions and talking about finding the zeros of polynomial function. So in topic 17, I mentioned that, hey, finding x-intercept is a lot like finding the zeros. What I mean by that is the arithmetic portion. It's basically the same thing. But the concept of x-intercept and zeros are not quite the same. So a function may not have a parabola may not have an x-intercept, but it will still have zeros of a function. So the ways we can find zero of a function is by factoring. Okay, we can do it by graphing. We can actually graph the function into the calculator and we can actually find the zeros. All right. But if you can see, like, I'm just going to use this problem, for example. All right, this x squared minus 4. If I want to do it by factoring, if I want to find a zero of the function by factoring, so remember, the zero function is referring to y is 0. Our job is solve for x. So this is a difference of square. So by factoring, all I'm going to do is simply just factor my difference of squares. So that'll be x and x, 2 and 2, 1 positive, 1 negative. Set each function equal to 0, solve for x. So one of the 0 is negative 2. The other 0 is positive 2. Okay, so this is not x-intercepts. Well, they are also x-intercepts too. But right now, if I ask you to find the zeros of a function, you don't have to put them in the order pairs. So x squared, let me show you where is it on the graphing calculator. Minus 4. Right? Here's a parabola. You see the two x-intercept. The zero of the function is referring to when you go to the table, and what you see is y equal to 0. If you go to x equal to negative 2, y is 0. Those zeros are referring to the zero of the function. Zero of the function means your y is 0. Your job is to find the x value. So it just turns out that negative 2, 0 and 2 comma 0 are also the x-intercepts. Now, if I would change this minus sign to a plus sign, then this function never cross over the x-axis, but they are still zeros to the function. So what happens if factoring doesn't work, right? You can't factor x squared plus 4. Graphing does not show you y is equal to 0. Then what do? Well, you stay tuned because there's a lot of stuff we have to learn before we can actually have an ultimate way to find the zeros. All right. So I'm not showing you this to scare you. A polynomial function p is given by this form: a sub n, x to the n power plus a sub n minus 1, x to n minus 1 power. So all this crazy thing is basically saying this is what a polynomial function is supposed to look like. A sub n minus 1, a sub n minus 2, a2, a1. Those are just coefficients. The n minus 1, n minus 2, and I'm saying down to square, 1 power, 0 power. Those are just your exponents. Okay. So polynomial function, the coefficients are always real numbers. That means there's no I. And exponents, the exponents are always whole numbers. Your exponent cannot be negative because negative exponents on a polynomial function actually force you to flip it, right? Negative exponent rule tell us to flip the base to the other side of a fraction. So, most of us know what a polynomial function looks like, okay? But I wrote this out so I can show you a couple of things. Number one, polynomial function is always expressed as in descending or ascending order on the exponents. Okay, either you go from the highest exponent going down or go from lowest exponent and written upward. The degree of a polynomial is the highest exponent, which denoted with the letter n. The degree of polynomial also identifies the type of polynomial function it is. Just like x to the third power, right? Plus 2x squared minus x plus 1, something like that. See, by the degree of the polynomial, that's a cubic function. But at the same time, the degree also tells you how many zeros at most the function should have. Okay, it tell you at most how many zeros the function should have. All right, so at most means it can have up to 3, but it can also have, this is weird, it can also have less. All right, what do I mean by that? It's kind of strange. It can be less by an even number. I'll actually mention that later on. I'll just give you a good example. X squared plus 2x, 4x plus 4. This is a parabola that will actually touch but not cross the x-axis. So technically, x-intercept, you only have one of them. So this problem, when it turns at the x-axis, okay, turns at the x-axis, that means you only have 1 zeros. Technically, you're supposed to have 2, but since both of them are the same one, then most people say, oh, I just have 1 zeros. Okay, so that can happen. Sometimes that does happen. All right, so the degree polynomial is the highest exponent. It tells me what type of polynomial function I have, and at most how many zero the polynomial function has. The leading term is called s of n, x to the n power. It's the term with the highest exponent that should be in the front. Leading coefficient is the coefficient of the leading term. Okay, whenever I use the wording leading coefficient, that means that's the coefficient of the leading term. If the leading term has exponents as x to the 0 power, that is simply just a constant function, because anything to the 0 power is just 1. But it is also considered as a polynomial function, believe it or not. X to the first power is called a linear function. Square is called quadratic. X to the third power is cubic function. If the highest exponent is 4, it's called quartic function. Anything higher than a 4 power, we actually do not name them anymore. Okay, and there's a reason why, and I think I kind of showed to you. X to the 4th power look a lot like x squared, which look a lot like x to the 6th power. Okay, the difference is just the u part is actually going to be wider. The base is actually wider. All right, but we are not going to talk much about that. But I do want you to know that, hey, the square, the 4th power, 6th power, all the even power graph look very similar. All the odd exponent function looks similar, other than of course linear functions. Linear function is just a straight line. All right, so think about that form, and let's take a look at some example real quick. All right, here's a polynomial function. Identify the degree. What is the highest exponent? Highest exponent I see is 3, right? So n is equal to 3. So that means negative 4x to the third, that should be the leading term. So I can rewrite this function as negative 4x to the third plus 2x squared plus 3, descending order on the exponents. Now, and I hope y'all remember the constant term is always the last term. That seems like there's no x to it because it's technically x to the 0 power. Anything to the 0 power is 1. 1 times 3 is still 3. That's why we don't write x to the 0 power. So we call the very last term, the one that without the x to the 0 power, the constant term. The leading coefficient is the coefficient of the leading term, which is negative 4. All right. So the next couple things is about behaviors of these polynomial functions, okay? The first one I want to show you is called the leading term test. If a sub n x of n is a leading term of a polynomial function, then the ending behavior of that graph, okay, the ending behavior of the graph, you know how you kind of keep on going up, 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 right? On both sides. Okay, those are called the ending behavior. As x keep on going to negative infinity, and as x going to positive infinity. The ending behavior as x keep on going to the right and left can be described as one of the four following scenarios. These are guaranteed, okay? These are guaranteed ending behavior of your polynomial functions. If n is even, okay, so that means square, fourth power, sixth power. If n is even and the leading coefficient called s of n, that's the leading coefficient, is greater than 0, that means positive. All right, your degree is even, your leading coefficient is positive, then it's guaranteed that the right side keep on going up, 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 up. The left side keep on going up, 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 up. As the x value keep on going right and left. If the degree is even, but this time the leading coefficient is negative, then it's guaranteed the right side and the left side will keep on going down, 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 down. So that's very similar to what we talk about in topic 17 about parabola open down and open up. It's about that A, about that leading coefficient, whether it's positive or negative. All right, it's guaranteed. So what I mean is, what does that have to do with 0? Well, if it's keep on going up, 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 if it's guaranteed to do that, that means it will not all of a sudden turn around and trying to curve back towards the x-axis. Okay, once it start going up, 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 it's not gonna all of a sudden turn and curve back towards the x-axis, because if it curves back towards the x-axis, that means there can be another 0 that I don't see in the graph. So I'm gonna change this x squared to x to the fourth power, okay? And you're probably not gonna see very much difference in the graph. A little bit. All right, so going up, 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 this is a fourth power. Coefficient is positive. So right here, as x keep on going to the right, excuse me, as x keep on going to the left, both y value keep on going up, 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 up. What that means is the y value will keep on increasing. Keep on going up, up, up means the y value keep on increasing. Check this out. If I will go to the right, that means x value gets bigger. Look at these y values. It's keep on getting larger and larger and larger. So it guarantees that it's not going to all of a sudden the y value decreased. That means it start curving back. Does that make sense? If a y value keep on increasing, that means the graph is keep on going up. If all of a sudden these y value drops from one to the next, that means curving back down again. As x keep on going to negative infinity, these y value also keep on getting what? Bigger and bigger and bigger. All right, that's what that means. If the degree is odd, but the coefficient is positive, that means the right side will always goes up, the left side will always go down. Okay, once it goes up, 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 keep on getting bigger and bigger y value. Once it keep on going down, all right, you will actually get more negative. The scribble part in the middle is actually what's going to happen around the x-axis. Okay, we'll talk more about that. But right now we are looking at the ending behavior. If the degree is odd, but the leading coefficient is negative, then the left side will keep on going up, the right side keep on going down. All right. So with these four scenarios in mind, use a four scenario to identify the end behavior. So I'm going to draw it, okay? This right here is all go by the leading coefficient. So this is the leading term, leading coefficient. Well, excuse me, it's go by the degree and the leading coefficient. So this example, degree is 4, so that's even. Coefficient is -2, which is negative, less than 0. So scribble, scribble, scribble. So which one is this one compared to the 4? Even, right? So you're gonna be what? The first or the second one? Well, since the leading coefficient is negative, you gotta be the second one. Both will go down. So scribble, scribble, scribble in the middle. right side keep on going down, the other side will also keep on going more negative. All right, this example, degree is 3, leading coefficient is positive 1. All right, so scribble, scribble, scribble. This got to be this one. Degree is odd, positive coefficient, right side goes up, left side goes down. Right side goes up, left side goes down. All right, so that also kind of tells you what approximately what the graph will look like. Okay, before you even graph it, you can kind of almost imagine what the graph will look like, because I can graph this to you, and sometimes you might not see exactly all the picture in within the negative 10 to 10 window. That's the reason why you kind of need to know approximately what these graph looks like. It helps. See, that's all it shows. All right, so you know this right here is keep on going down, down, down. That side right here is keep on going up, 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 without you seeing the entire picture. All right. Let's take a look at another concept. Even odd multiplicity. This will tell you what's happening around the x-axis. All right, the even and odd multiplicity on a factor of a polynomial function. On a factor. So that means I have a polynomial function. I factored it. And the exponent on the factor tells me whether the graph of the function will cross or turn at the x-axis. Okay. How did I know earlier that x squared plus 4x plus 4 will turn? Well, I knew that because I know if I factor this, if I factored it, this is a perfect square binomial. I make a big deal about that before because perfect square binomial is where the two parentheses are exactly the same, right? 2 on the outside, 2 on the inside, that give me 4x in the middle. X plus 2 times x plus 2. If they are exactly the same, you can write this as x plus 2 whole thing squared. So if the factor, right, if your polynomial is factored in, where the exponent k right here is bigger than 1, okay? If this thing is a factor of a polynomial function, all right, and x minus c is not a factor, and it's not another one, it's not another one. If k is odd, if this exponent is odd, then the graph will definitely cross at the x-axis. And the point it will cross the x-axis at c comma 0. So what's c? C is what? Is the x-intercept. It's the x value of the x-intercept. If k is even, like this 2, that tells me that the graph, it will turn at the what? Will turn at the x-axis. So technically you have 2 zeros, 2 x-intercept, but since the 2 are exactly the same, you will only end up with 1. Okay. So if the exponent on the factor of the polynomial is odd, then the function will cross over the x-axis at that point. That's where your x-intercept is. If the exponent on the factor of a polynomial is even, that tells you the graph will literally turn at the x-axis. Again, that is also your x-intercept. Okay, it will turn over there. When adding up the multiplicity, it will always equal to the degree of the polynomial. Because remember, degree of polynomial also tells me at most how many zeros I should have. So this example, I should have at most 2, right? But it turns out I only have 1 of them because the 2 are exactly the same. So let's give it a try, okay? I just did this one. factor the quadratic function, state the multiplicity, and below each multiplicity we will state whether the graph will cross or turn. All right, so I just did this one. So I'm gonna just rewrite this again, okay? So that's gonna be x plus 2 times x plus 2, which literally is x plus 2 whole thing squared. So the multiplicity is even. You can say 2. Okay, multiplicity is 2, the exponent on the factor. And right below that, you will tell me whether it will cross or turn. If it's even, it will always turn at the x-axis. All right, and at what point does it turn? Well, all you have to do is set the function equal to 0 and solve for x, which I just show you is that it will turn at -2. If I factor this difference of squares, then you will see this is simply just x plus 2 times x minus 2. And what is the exponent up here? What's the exponent? You don't see one, right? So that must be 1. So number 2, state the multiplicity. Multiplicity is 1 and the 1. I have 2 zeros, so I will write 2 multiplicities. I have 2 factor, 2 zeros. Number 3, since both of them are odd, since the multiplicity is odd, then you will cross. So what would a cross at? Where would a cross at? All you have to do to find out where it will cross at is set the function equal to 0, right? Since I already factored it, I can just simply quickly solve for set each factor equal to 0, and it will tell me exactly where it will cross at or turn at. So it will turn at the x-intercept 2, 0 and -2, 0. Excuse me, it will cross at -2, 0, 2, 0. Okay, so leading term test, even and odd multiplicity. All right, the next one is called the intermediate value theorem. I'm gonna see if I got a good function here so I can graph it. Yeah, I do. Intermediate value theorem says this. Let f to be a polynomial function. The intermediate value theorem for algebra states that if f of a and f of b have opposite signs. So what's going on? Well, what's going on here is it's a lot like the x1 and x2. We talk about the horizontal line test, the 1-to-1 function. So that simply means, okay, I have two x value called a and b. I have two x value called a and b. If I substitute both x value into the function, then f of a is referring to the y value of it, the y value. So if I pick an x value, put into my function, what comes out is a y value. If I take another x value, put into my function, and what come out of it is another y value. If those two y values have opposite signs, if those two y values have opposite signs, then there must exist at least one value of c, which is your 0, okay, a value of c between a and b, for which f of c is equal to 0. Well, so what that means is c is the 0 of the function, okay, the 0 of the function. So if I pick this x value, call it a, that, just pick anyone right here, that x value, call it the b. Their y value, if they have opposite sign, that one is positive, one is negative, of course, then there got to be a number, an x value called c in between those two x value, where that f of c, where if I substitute that number c back into the function, it will always come out to be 0. So remember, the 0 of a function means y is 0. So whenever you see a y value equal to 0, that x value is the 0 of the function. Okay, so let me show you in a graph, so you understand. Okay, so this example, I simply want you to put this function in the graphing calculator and then look up x equal to 3. What's the y value? So cubic function, oops, x to the third minus 5x squared plus 3x plus 6. Ah, darn it. X to the third. 5x squared. All right, here's a cubic function. Okay, so this one should be scribble, scribble, scribble. Right side goes up, left side goes down. There you go. Right side goes up, left side goes down. Okay, I'm gonna go to my table. I'm gonna look up x equal to 3. And the y value is -3. When x equal to 4, do you see x equal to 4? The y value is +2. All right, so what's going on? Well, see, when you have two x value, right? Two different x value. If the y value have opposite sign, that means the graph has actually crossed over the x-axis. Because one y value is negative, one value is positive. The only way that can happen, right? 3 and 4. If one x value, if one y value is positive, one is negative, that means the function has crossed over the x-axis. If it crossed over the x-axis, then there got to be a 0 in between them. But right now, my calculator doesn't tell me. See right here, when x equal to 2, y is 0, right? Everybody see that? So that's 1, 0 of the function. But there's nowhere else. But you see, between -1 to 0, the y value also have opposite sign. So whenever I have opposite sign, that kind of tells me that, hey, there is going to be a 0 that is in between 0 to -1 on the x-axis. When the y value changing signs, that tells me that there got to be an x value, a 0 that's between 3 to 4. I just don't know what they are yet. Okay. There's a 0 here. There's a 0 there. I just don't know what they are. The only thing I know is they are not integers. So we will have to learn other things, you know what I'm saying, to actually figure it out. So by the intermediate value theorem, is f of 3 the y value, right? If I substitute 3 into the function, substitute 4 into the function, does f of 3, f of 4 have opposite sign? Where there exists at least one real 0 between them? The answer is yes. As long as they have opposite sign, they got to be a 0 between 3 to 4. All right. So I'm gonna stop here. This is a good place to stop because these problem has a lot of steps. So basically, the next part, I will show you how to find the zeros of a polynomial function by factoring. I'm gonna show you how to graph it also. All right.